So hi and welcome to this video on the Labyrinth of Douglas, a brain teaser and exercise on futureskill.com. So this is actually an old puzzle from 1990, so not ancient but still old, called Theseus and the Minotaur. And I used to have this in a class I had at school in Chalmers. And I guess we solved this with functional programming Haskell, but we're not going to torture ourselves. That was actually very fun. But we're going to do it with a more modern language, I'm sure, here, like Python or Java or C# or something like that. But let's look at the problem here. So I'm going to, in this video, explain the problem and explain what you get as input, the API, and how you send back a solution. But I'm not going to go through how to solve it. There will be a separate video on that with more of an explainer on how you can code the solution for Labyrinth of Douglas. So let's go over to this like whiteboard scenario that we have here. So how this game works is that we have, in our case, instead of Theseus being the original hero and the Minotaur being the original foe, we have Katniss and Douglas, our characters. So Katniss is the hero up here at the top. And then we have Douglas in the bottom left in this example. So he's trying to capture the cat. So how does the game work? Well, Katniss takes one step at a time and only in cardinal directions. So we only move like this, so not diagonally. And Katniss has one step every time and Douglas has two. So how is this even possible? Well, the cat, it wants to go to the star. That's the goal, is the star that you see here. And to get there, Katniss will go one step at a time, one orthogonal cardinal step at a time, donk, 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 for example. And Douglas will move twice for every such move where Katniss takes one step. So how is this even possible? Well, let's take an example of, so how it is possible to give that away immediately is that Douglas might be have twice the speed of Katniss, but he is also very predictable. So he always uses the same algorithm to move, and that's how we can outsmart him. And one way that we might try this is if we start to walk with Katniss to here. The algorithm that Douglas uses is that he will always check first if he can move horizontally to get closer, and then in the second step he will check vertically if the horizontal move is not possible. If he can move closer horizontally, he will do so. Oh yeah, and I should mention there is also walls. So we see walls here, the red ones; those are impenetrable. So what happens here? If Katniss moves one step to the right, then Douglas will check. Can I move closer horizontally? Yes, then he will do that. And the second step he takes, second step in the same move, he will check horizontally again, but he can't get any closer. He's on the same x-coordinate as the cat. So then he will check vertically. Can I move closer vertically? And yes, he can. So he will move there. And now, unfortunately, it's trickier here for the cat. If the cat would continue to go towards the star, then Douglas would go one step to the right. Okay, not become bigger though, but he would take one step to the right here. And then he would check horizontally again, can't get any closer. Check vertically, yes, that's possible. Then he will end up there. And now Katniss will actually reach the star, so reach the goal. The problem is that in this case, Douglas gets to do the final move. Again, check horizontally, possible, yes. Not now, it's not. So then he will take a vertical step and end up catching the cat. So that was not a solution to this one. So what is a solution? Well, one way, for example, would be to pass. So that's also an important move. I think you can actually solve this one without passing, but in some cases you cannot solve the maze without passing. So sometimes it's like a crucial move to do. So in this case, Katniss can pass, give the turn to Douglas. Douglas will check horizontally, can't get closer, so he will go vertically. Check horizontally again, can't get closer, so he will go vertically. And end up like this. And now in the second step, then Katniss will take one step to the right. Douglas will make his move, check horizontally. He can get closer and go in here. And this is of course the problem for Douglas. It's a really stupid move because now he'll be stuck. If he could instead be a clever dog and say, okay, I want to move vertically first and then horizontally, then he would catch Katniss immediately. But then this is not an interesting maze anymore. So the puzzle works this way, that he will check horizontally, yes, I can go closer. Then he can check horizontally, can't get closer, vertically can't get closer because there's a wall, it will end up like this. And then Katniss will move, Douglas pass, can't get closer because of the walls. And then Katniss will move again like this and reach the star unscathed. So this is a solution to this very small example puzzle that we have here. And now on our page then, you can solve this puzzle both manually and using code. So if we start just to show how the same thing that I just showed here, how it works with interact, then there's two ways actually to do this. I can use the keyboard, which I'm going to do now, or maybe I should actually use this button. So these show possible moves. So I can go here, and the way to solve this, it's similar to what I just shown. I go to the left now, then here. Douglas has the opportunity to do two moves, and if we look here, maybe we just go back here to the very start and look at what the notation is. There's a little bug here also, which is on me. You can actually take a step to the left here as well. For some reason that circle isn't showing. I'm going to fix that at some point. But the notation here is that Katniss moves down, and there's an arrow there, to 1,1. And what is 1,1? Well, if I push this one, x, y here, you will see. Now, fortunately, background I made was very light, so it's hard to see, but you can see the xy coordinates of each square here when you press this button, like you see here. So 1,1 means that the cat ended up on 1,1 after moving down. Douglas then started in 0,3, moved one step to the right to get closer horizontally, and then this is the passing move, because he couldn't get any closer, neither horizontally or vertically. Okay, now maybe I pushed something, I don't know, but let's go back here. So the notation then here is that he ends up on 1,3 after a right move and then passing. And if we continue, we take a move right, 2,1, Douglas moves right and then passes to 2,3. And here we move to 3,1. Douglas, we see the first move at the same time as the cat to get some kind of flow. If I press again, we'll see the second part of Douglas's move. So he moved right and then up as part of his two mover. And we can see the algorithm get closer horizontally, then that's not possible anymore. Then he goes a vertical move. And of course, it's very close to catching Katniss here. Moves right, moves up to 3,2. Then Katniss moves to the left to 2,1. Douglas follows to 2,2. And then Katniss goes to 1,1 and Douglas continues here. We go up, Douglas stays. And then here we're going to go... oh yeah, I need to press resume interact. Okay, let's do it again. So I use the buttons now. I move here. Then I go back to the left. And I go press up, press left. And here we see Douglas getting stuck again in some kind of problematic square for him. And that's how we solve the puzzle. Because now we can go around all the way to the star. And then we have reached the goal and solved the maze. So this is one way to solve it, using either clicking on the yellow circles or using the arrow keys on your keyboard, using interact. If the interact breaks, like it did now when I was showing, then you press resume interact and you're back and can try it again. So when you do coding, well, first off, you can choose any language here, like C++, C#, Java, JavaScript, etc. And the boilerplate code, the skeleton code here changes. If we go back to Python, since that's my favorite, it looks like this. You can read about the problem here, and that's kind of what I'm explaining now in this video. it explains well the input that you get. So in the make move method that you have here, you get Katniss's position and Douglas position as x comma y, and those x comma y values correspond to what you see as you toggle here with this button. There are bigger levels to solve here, for example, and also here you can see vaguely see the xy coordinates pressing that button. So that you get as input the position, the starting position, well actually the position for each move that you make, you get here. And then there is also an API. So there is an API to get the width. This one also changes with the language, by the way, so it might look different in Java, for example, but we'll show the Python example here. So you can get the width, that's just the number of cells you have horizontally, so here it would be 4. You can get the height, that would also be 4 here in this case. Actually they are all square in practice, but could be another could be another rectangle as well. So get vertical walls, that one you get as a list of integers. So the inner list here is simply x comma y. So you get the inner list as a too long list of integers x comma y, which corresponds exactly to the square coordinates that we see here as x comma y, like 0, 0, 1, 0, and so forth. So if I do a printing here in can do a printing here and then run code. So I'm printing just to show how the walls look. Yeah. So we get them as a list of 2 long lists. So the vertical walls we'll see at 1, 0, and let's check which one that is. 1, 0, we see that this square is 1, 0, and the vertical walls are given as the square to the left of the vertical walls. So this wall here is 1, 0. The other one we got was 0, 1. That wall is from this square to the right of that square. So it's only 2 vertical walls, 1, 0, 0, 1. And then if we look at, let's do the same thing with horizontal walls instead. Then I just need to change this a little bit. Yeah, we can actually skip the second part here, because that's just how I save them internally using an index instead. So let's pause and check here. So horizontal walls that's a longer list, as we can see. There are many more horizontal walls in this one. If you look at the first one, there is a 0, 0 here. So if we call the API for horizontal walls, we get 0, 0. That is that square here. The horizontal wall is right below it. Then we will get 2, 0, as we see here. Yeah, 2, 0. Then we get 1, 1. That is this square. So there is a wall behind or below that one. 2, 1, 0, 2. So 2, 1 is this wall. 0, 2 is this one. And then we also get 1, 2, 2, 2. So we have a list, a longer list of short 2 long lists, x, y, of all the squares, which has a horizontal wall below it. So then we're gone through get width, get height, get vertical walls, get horizontal walls. There's just one more, get goal. So that is a 2 long list of integers, same x, y as here. And that is just to show where the goal is. So in this case, the goal is 2, 0. So if we use the API to get the goal, we would get 2, 0 for this square here. And then what do we return? Well, in each step when we are called the make move method, the main method is make move. When that is called, we return a list of integers. And that is the x, y for Katniss to walk to. You can also send the current x, y where Katniss is already standing. Like I showed here in this example, when we wanted to pass, we send in the 0, 0 that we are standing on. So that's to pass. We send in the current location. Otherwise, we send the square we want to walk to. Obviously, that's the only possible squares are the ones that are next to Katniss currently. So if you are on 1,1, you can either send in 1,0 to move up, 2,1 to move to the right, or 1,1 to make a passing move. There is also a limit on the number of moves you can make. So if you just pass all the time, you're going to run out of moves. I think it's 200 moves is the maximum that's set before you have to reach the goal, just to get to an end point there. So make move is the one you should call. Then of course what you can do is you can solve the problem like the solution here and put it in a cache, like a list of moves to return, and then every time make move is called, you just send back the next square to go to with Katniss, like these ones here. So as I said, I'm not going to go through the code now and how to solve it. I'm just shown what the problem is, the rules of it, how to solve it manually. We talked about the code. You can do it in different languages, and what you get as input and how you access the API to get more information that you need, and then return all the moves that you're going to move to and to solve the problem. And maybe just end here by showing the biggest level, level 6. I'm not going to show all of it, but it's the same principle, just a lot more squares, and it takes a little bit longer to solve. So here is the start of the solution, and if you look at the very end, it's going to look like this, and Katniss reaches the goal. So that's the Labyrinth of Douglas. Good luck solving it.